This is an explanation video for 2 TVWO. It's about chapter 8 and I'm going to discuss exercises 12 and 24. First, exercise 12. So this is exercise 12. It says, calculate the area of each of the parallelograms below in squared centimeters. Now there are 4 parallelograms and I'm going to discuss all of them. As you can see, it says you have to give it in squared centimeters, your answer. Sometimes it's given in millimeters, sometimes centimeters, here again millimeters, and here again centimeters. So whenever we have our answer, every single time we're going to check if we need to change it into squared centimeters or not. To calculate the area of parallelogram ABCD, you need to do base times height. With base, we mean an outside of the parallelogram, and with height, we mean the corresponding height of that base. So here's a picture. You don't have to make a sketch. Of course, it's handy, but you don't have to do it. It costs a lot of time. If you can do it without a sketch, it's fine, but you do have to write down all calculations and very, very clear. So you have to write down what you're calculating, the area, and you have to write down which parallelogram. In this case, it's ABCD. So make sure you write that down and then an is sign, and then you start with the calculation. A lot of students, they start with the calculation immediately, but then when you look it up later, then you can't see what the calculation is about anymore. So you really have to write that down. Now, let me check where the base is. I'm gonna go around the parallelogram. The base is always an outside. I don't know this outside. I don't know this outside. I don't know this outside, but I do know this one. This is 17 millimeters. Now, automatically, this side is also 17 millimeters. So sometimes that's helpful. Now, let's have a look at this one. I'm going along this side with my finger, and I'm going to check if there's a 90-degree sign. Yes, there's a 90-degree sign here. So that means that this little line is the corresponding height. Let me write it down. The base is 70, and the corresponding height is 30. Now, I'm going to calculate that. So that's area ABCD is 7 times 3 is 21. So that means that 70 times 30 is 2100 squared millimeters. But again, in the question it says that you had to give it in squared centimeters. So the area of parallelogram ABCD is, it goes with 2 steps in one time because it's squared here. So it's 21 squared centimeters. That's the answer. The second parallelogram, again, area KLMN is base times height. Now I want to write down what the numbers are here. I'm going to look at the outside for a base. It can be any outside, it doesn't really matter, but you have to look for the corresponding height. Okay, so sometimes you don't have that and then you have to look for another base. Now, this can be the base, but if I go along this side of my finger, I don't see a 90-degree sign. So I can't use this as a base. This one, no corresponding height either. If I'm going to look at this one, yes, there's a 90-degree sign here. So you know what? I'm going to use this as a base. So that's 6 plus 3 is 9. That is the base. And the height is this little part. But I don't know what the length is of that part. So perhaps I have to calculate it. Now, a lot of the times you come to this point that you can go further because you don't have this information. Now, simply write down a question mark. And you have the knowledge of Pythagoras theorem. You have to use it a lot. This is a right angle triangle, this one. And that triangle I'm going to use. I'm going to write a letter here, for example, P. All right, now I want to calculate PN. Now, I do know what this PM is, it's 3 centimeters. I also have to know what this is, and then I can calculate the question mark. What is MN? Well, this is 5, and in a parallelogram, all opposite sides are the same length. So this is also 5 centimeters. So now, here it is, my right angle triangle. I'm going to do Pythagoras theorem. Side, square, and then this table, remember? First you write down the 2 sides connected to the 90-degree sign. PN is connected to the 90-degree sign. Also PM is connected to the 90-degree sign. And the hypotenuse is the last one, is MN. I'm going to fill in whatever I know. I don't know this one. I do know this one. And I do know this one. I'm going to do them squared. 3 squared is 9. 5 squared is 25. Plus 9 is 25. I believe that's 16. Now, I'm going to write down that Pn squared is 16. So Pn is square root 16. I know what square root 16 is. It's 4. So this question mark is gone. This is 4. Now I can write down that the corresponding height is 4. 9 times 4, I know what it is. So the area of KLMN is 36. The unit was centimeters, so this is centimeters squared. And this is the answer. Done. This third parallelogram. Again, the base has to be an outside. This can be an outside, or this can be an outside, or this one, or this one. I immediately see the 90-degree sign is here, so I'm going to use SR as an outside, which is 24. And then this is the corresponding height. Okay, so base is 24, and the corresponding height, I don't know it yet, so dot, 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 dot. I don't know what TU is yet. I have to figure it out. In the previous parallelogram, we saw that we have to do Pythagoras theorem. You saw that there was a right angled triangle there, so here we have to do exactly the same. But there's a small problem here because we don't see a right angled triangle, so we have to make one. Now, I want to use this height because that is the height that I want to know. But yeah, of course, there is no right angle triangle here. What you can do is this height, if I move it, you see me moving my pen here, everywhere it's the same. It doesn't matter if this height TU is here. It doesn't matter for the length. It can be here or it can be here. Everywhere it's the same part. You see, it's the same length. So you know what, I'm going to move it. I'm going to move it to a place where I can make a right angle triangle. And I am going to move it towards this point, Q. Let me do that with a red pencil. And this is exactly the same length as this. So it doesn't matter if I calculate this line or this line. Now, the advantage of this line is that it makes a right angle triangle here. So this is the 90-degree sign again, and then this is the right angle triangle. You see? Okay, so write a letter here, it makes it easier. For example, A. And now I want to calculate, I'm going to do Pythagoras theorem in right angle triangle ARQ, where I can calculate AQ. So here we go. Side square. The two sides that are connected to the 90-degree sign are AQ and AR. The hypotenuse is the opposite of the 90-degree sign, which is QR. AQ is, I don't know yet. That's the whole point here. I'm going to calculate that. AR. Okay, that's a small problem. I know the whole length from T to R is 12. And I know from U to Q it's 4. So what do you think is the leftover for AR? If this whole part is 12, this little part is 4, what's the leftover for AR, this little part? Yes, you have to do 12 minus 4. Do you see that? This is 12. From here to here, it's 4. You can also write it down. So this whole length is 12. From here to here, it's 4. So what's the leftover for this little part? It's 8. So from A to R, it's 8. And then QR is, it says 17. So 17. Now I'm going to do it squared. I don't know this one. 8 squared is 64. And 17 squared is, you may use your calculator here, is 289. Now, I need to calculate this. I'm going to do 289 minus 64. So this answer, minus 64, is 225. So I'm going to write down that this is 225. AQ squared is 225. AQ is the square root of 225. So AQ is 15. Of course, you knew this one, right? Now we're going to fill it in. 24 times 15, and again, calculate it, 360. So the area of PQRS is 360 squared millimeters. I'm going to change that into squared centimeters, and that goes 2 steps at a time. So it's 3.6 squared centimeters, and done. And this is the last parallelogram of exercise 12. You have to calculate the area of VWXY. You have to do base times height. Let's look at the outsides. I know this outside is 5, and I know this outside is 8.5. Automatically this one is also 5, and this one is also 8.5. Okay, I'm gonna go along this side with my finger, and I'm gonna look for the 90-degree sign. I don't see it there, but I can see that this line is extended towards this side, and here is 90-degree sign. That's also okay, which means that this part, so X is the corresponding height. So this is what I want to know for the corresponding height, and I'm going to use this as a base. Some students use the whole length, so that's 5 plus 4 as a base, but that's actually wrong, because this is just air. This is in the air, and this is what we need to calculate. This is the parallelogram. This is what it's about. So we're only going to use 5. 5 is the base, and the height is Zx. I still need to calculate that one, so therefore I wrote down a question mark. Now, again, Pythagoras theorem. Luckily, the right angle triangle is already here. We know 4, we don't know this one, and we have to know this one. What is it? It's the same as 8.5. So this is 8.5 centimeters. And now I'm gonna do the table again. Side square. Yes, you need to do the table every single time. Write it all down and the calculations here if you want to have all points on a test, okay? It's really important. Now, the sides that are connected to the 90-degree sign are WZ, that's 4, and also ZX. We don't know that one, we're going to calculate it. And then the hypotenuse is WX. The hypotenuse is 8.5. Now, 4 squared is 16. We don't know this one. And 8.5 squared is 72.25. 72.25. I'm gonna do them minus each other. So 72.25 minus 16, which is 56.25. And that is what I want to know. You have to write this down, okay? So Zx is the square root of 56.25. So this is the square root of 56.25 is, sometimes you get a square root as an answer, and then you have to use this button on your calculator with the 2 arrows here, and you're going to change it into a normal number, okay? So some settings in your calculator are that you get a square root as an answer, which is really annoying, so use this button. Now, the answer is 7.5. Is 7.5. Okay, I'm going to use it here. 5 times 7.5, which is 37.5. And it's in centimeters, so squared centimeters. And then this is the answer. We are discussing exercise 24. It says a circular pond has a radius of 120 centimeters. Calculate the area of the pond in square meters. Round your answer to 1 decimal place. So this is the circular pond, and it has a radius of 120 centimeters. Radius is from the midpoint to the outside of the circle, 120 centimeters. Now, The area of a circle, the formula is area circle is pi times r squared. R stands for radius, so that's the midpoint to the outside. Now I'm going to fill it in. The area of this circle is pi times 120 squared. Of course, I need my calculator for this. I'm going to do pi times 120 squared. Pi, the button is here. Pi times 120 squared is 14,400 pi. Sometimes I have pi in my answer, which is really annoying. I just want to know the answer. I'm going to use this button again with the 2 arrows. Press it, and then it says 45,238.93 and more decimal numbers. Let me do the waves, and then it's 45238.93. This is in squared centimeters, but in the exercise it says that we have to round off to squared meters. So I'm going to change that. From centimeters to meters is 2 steps, but this is about area. So I'm going to move the comma 4 places here. So that's 1, 2, 3, 4. So it's 4.5. We have to round off to 1 decimal place. Now the 2 is lower than a 5, so it stays a 5, not becoming a 6. So 4.5 squared meters. And then here is the waves because it's rounded off. And to make it more complete, I write down the area of a circle is 4.5 squared meters. That's it. In exercise B, it says, what is the area of a circular pond in squared meters when the diameter is 200 centimeters? Now a diameter is this whole length. So that's a radius plus the radius. So the diameter is 200 centimeters. And again, I have to give the answer in squared meters. Now, I'm gonna do a different approach here. I'm going to change this into meters first. So 200 centimeters is 2 meters. I'm going to use the 2 meters instead of the 200 centimeters. Now it's already changed into meters. Now I'm going to fill it in. I want to fill in a radius, but this is the diameter. So what am I going to do? I'm going to do it divided by 2 to know the radius. So the radius is 2, because this is 2 meters, divided by 2. I'm going to take the half of it, which is 1. So it's 1 meter, the radius. Now, fill it in. Pi times 1 squared. This is a little bit of an odd one because we're working with 1. What is 1 squared? It's just 1. So pi times 1. And what is pi times 1? It's just pi. Now, what is pi? It's 3.141592. And so on and so on and so on. You can also look it up in your calculator. But since I already know it, I'm just going to do 3.14, what should I say? 3.1 then. Of course, it's more exact if you say it's pi squared meters. But since that sounds a little bit weird whenever you're, for example, doing something in the garden with a circle or whatever, it's easier to use this number 3.1. Okay, so this was it. Hey, this was a video about exercises 12 and 24. Thanks for watching.